Right, let's take a look at our page 5 after you have watched the video from the QR code. So now we are considering a right square pyramid. The word right over here refers to our base of the pyramid. So this right square over here tells us that this portion is a square. So the information given, M is the midpoint of the line BC, and then N is the midpoint of the base. So this portion is right in the center of the square base. They want us to draw and label the vertical height of the pyramid. So let's start with the first one. So the vertical height must start from the vertex and you will drop down to the center of that square base. So that's our vertical height. Let's call it part 1. Next, we need the slant height. The slant height on the lateral face VBC, so that is the one on the right hand side. This will be our slant height. They want us to name the right angle triangle formed by the vertical height and the slant height, basically the two dotted lines that we have just drawn. So our right angle triangle will be VNM. Triangle VNM. Now they give us more information. AB is 16 cm. So the side of that square, 16 cm, half of it will be 8 cm. So that is our NM over here, 8 cm. VN, they provided, that's a vertical height 15 cm. And now they want the length of VM, which is our slant height. So if we were to, this may look quite confusing. So if we were to extract out what we have just drawn, okay, the vertex on top and the middle of the square base, M over here, the midpoint of our BC, put in all the information that we have so far. Okay, so NM will be our 8 cm. Our VN is 15. We want to find VM. So that reminds us of our Pythagoras theorem, which can be used for all right angle triangles. So our VM is going to be the square root of 15 square plus 8 square. You can work it out from the 8 square plus 15 square equals to VM square. Then subsequently, you still need the square root. And now, in one step, we get the distance, the length of the slant height to be 17 cm. And finally, they want us to find the area of the lateral face VBC. So our primary school mathematics tells us that area will be our half times the base. The base was given to be 16 times the perpendicular height of that lateral face. So work all this out, we get 136 square centimeters. Okay, so we move on to the bottom of the page. If we have a square pyramid over here, you open it up. This is what you will see. This is called the net. And we want to talk about the total area of the square pyramid. We will have one square base and 4 lateral faces, and 4 of them are the same. Whereas if you have something like a pentagonal pyramid with its net, so we're talking about a 5-sided base, we will have 5 lateral faces. So the total surface area of a pyramid is the total area of the net. This must be the base area plus total area of lateral faces. So let's try this. Practice number 1. Find the total surface area of this square pyramid. Our base is simply 7 square. Our lateral face, since it is a square, right? Our lateral face will be a triangle. Half times base times the, in this case, the slant height, which is 12. So total area, we start with the base, 7 square. Plus, there are 4 lateral faces, all they are the same. Half times the base of 7 times the perpendicular height of that triangle, which is going to be the slant height in this case. So we end up with 49 plus, so work this out, 14 times 12. So 168 add everything up, we get 217 square centimeters. Moving on to the next page. Okay, so this will be your homework question. We've got total surface area of this triangular pyramid. Total, there will be one base and 3 lateral faces. All of them are different triangles. So make sure you are able to identify which is the corresponding heights to the corresponding bases. So do this in class now. Not homework, do it now. Do now. We take a look at practice number 3. A right square pyramid, same slant height for all lateral faces. So this over here, 2.7 is the length of the edge. Okay, so this is not the slant height. They want us now to find the slant height of the lateral face triangle VBC. So they are, part 1 is asking for this dotted line's length. Again, we are able to identify a right angle triangle. So I'm going to extract it out. We've got our V over here, C, and if I were to call this midpoint M, let's just call this M. 2.7 is our VC. Our base, MC, is going to be half of 2. So this gives us 1. And now, VM is our slant height. We are going to be using Pythagoras theorem again. VM, when you square it, plus your 1 square is supposed to give us 2.7 square. Rearrange, make VM the subject. 2.7 square, take away 1 square with a square root. So put this in your calculator. You get 2.5079. Then, because the answer is not exact, you need to round off to 3 significant figures, 2.51 centimeters. And now they want us to find the total surface area of the pyramid. We already have the height VM. So use your primary school half times base times height. You multiply by 4 triangles. Don't forget the square base. And you have done part 2. So this answer for you to check. Move on to the next one. This time we have an irregular pyramid. So the base is no longer a square. And as a result, there will be different slant heights for the different lateral surfaces. So an example over here is a rectangular base. No more a square. They gave us the height. The vertical height of this pyramid is 12 centimeters. PQ, which is going to be the same as SR, will be 10. So the mid over here gives us 5 centimeters. Similarly, over here, the mid value will be 4 centimeters. So they want us to find the slant height of the lateral faces. We've got 2 different lateral faces over here. Let's call this M. Okay, this midpoint over here, let's call it M. And let's call this over here T. So choose a letter that has not been used yet. We start with the first one. Let me find VM. To do so, I will need to create my right angle triangle using the perpendicular height. So I've just drawn one. I'm going to extract it out so that it's easier to see. N is our midpoint. V is the vertex. And here I've got M. Our vertical height was given in the question to be 12. So now I need my distance MN. Take note, N will be right in the center of the pyramid. So our MN distance, this portion will be the same as this portion. They are the same, which means it is 4 centimeters. And now we have our right angle triangle. We just need to find VM. So by Pythagoras theorem, our VM will be the square root of 4 square plus 12 square. So square root of 160 gives us 12.649. Always put on a 5SF first, then you round off 12.6 centimeter. So this is our slant height for our lateral face VQP. Okay, next one. So this one will be our 12.6 cm. Next, we still have our VQR that we need to find out. So let me just use a different color. This time, our triangle is here. I find it is a little easier to see. Okay, extract out the triangle. V on top, N is still right in the middle, and we created a point T over here for our convenience. Perpendicular height is still 12. Now we require NT. NT refers to this portion, which is the same as this portion, which is simply 10 divided by 2. So that gives us 5. Therefore, VT must be the square root of 12 square plus 5 square. That gives us 13 centimeters. Okay, so this slant height will be 13 cm. Next part, find the total surface area of the pyramid. So that requires us to have the base area, and then we add up all the 4 lateral faces. So let's do the simple one first. Our base is a rectangle, 10 times 8. Okay, now we do the lateral face, the triangle. The first triangle I want to deal with is this one over here, the one that is facing us. Okay, VPQ. So we have half times the base, which is 10, times the perpendicular height. Early on, we found VM. So this is the reason why we put our 5SF first, 12.649. Because if you use 12.6, it is no longer accurate. So this is the area for the triangle that's facing us. But because it is a rectangular pyramid, the triangle directly opposite, meaning VSR, is exactly the same. So you multiply whatever this is by 2. Front and back triangles are the same. Now we do half times the base. This time the base will be 8. The perpendicular height we calculated earlier on, it was 13. So this is the area for the triangle on the right hand side called VQR. You multiply by 2 again, because there's another one on the left which is the same, VPS. You add all these up and round it off. Your answer should be your 310 square centimeters. Go and try it out. Practice number 5. Again, we have a rectangular pyramid. Height is 12. AB will be 10. So immediately go and find out the midpoint over here. This will be 5 and 5. And on the other side, we have 12 centimeters again. So that gives us 6 and 6. So find the slant height Vx. That requires you to form your right angle triangle again. Vx, our base of this triangle is going to be 5. Okay, so this portion is the same as this portion. That's 5. By Pythagoras theorem, go and figure out what is Vx. Do this now. The slant edge VC. So let's find where VC is. Okay. So they want this distance now. Based on our drawing, I'm now going to extract the relevant right angle triangle. So that is V. This is our midpoint, X, and C. We're going to find this distance. Our Vx was found in part A already, and then we require our XC value, which is here, simply half of 12, which gives us 6. So 13, 6, surely you can find VC by yourself. And then total surface area of the pyramid, you've got your rectangle at the bottom, you've got your slant height for the lateral face VBC, multiply by 2 for the other side, repeat the process again for the front triangle facing you, VAB, as well as the one behind, which is exactly the same. So all these, do it in class now.